Section 7-3, Equations with Fractional Coefficients. And as you can guess, our goal today is going to be able to solve equations that have fractional coefficients. If you remember the word coefficient from chapter 4, coefficient talks about the number in front of a variable term. So for 3x, 3 is the coefficient. For negative 4, xy squared, negative 4 is the coefficient. In this case, excuse me, in this chapter we're going to have terms that have fractional coefficients like 1/2 x or 7/8 x squared. And sometimes they're written as fractions where you would have like x over 2. Those kind of terms are what we're dealing with in this section. In order to get rid of those terms, you're going to get rid of the fractions of an equation by multiplying all terms in that equation by the LCD. If you look at all the fractions, figure out the LCD, multiply by that number, and you should have no more fractions left. So let's talk about some ways that we can solve this equation. If you notice, it has fractional coefficients, just like this chapter is explaining. This fractional coefficient is 4/3, this one is 2/5. This is not a coefficient, but it is a fraction, so I have this crazy looking equation with a whole bunch of fractions in it. I can get rid of these fractions by multiplying by the LCD. And in this case, I'm looking at all of my denominators, 3, 5, and 3, and I can determine that my LCD is 15. So everything gets multiplied by 15. Notice I'm not multiplying the top and bottom by 15. I am multiplying every term in the equation by 15. Times 3/5. At this step, I should be doing a whole bunch of cross-canceling, and that's what's going to get rid of the crazy denominators. 15 over 3 are both divisible by 3, so I'm left with 5. This term right here becomes 5, 4y plus 1. Minus, right here, 15 and 5 are both divisible by 5, so I'm left with 3, 2y plus 1. Right here, 15 and 5 again are both divisible by 5, so this equals 9. That's 3 times 3. This equation, much more reasonable for us to solve. No more fractions. Distribute 20y plus 5 minus 6y minus 3 equals 9. I'm going to combine my like terms. I have 14y. I have right here 5 minus 3 is 2 equals 9. Subtract 2. 14y equals 7. So I have to divide both sides by 14. I get that y equals 7 over 14 as a fraction, which reduces to 1/2. And that's the answer that we're looking for. If I go back up here and plug in 1/2, this term minus this term should equal 3/5. Here's another equation with fractional coefficients. Now each term of this equation is not a fraction, but there are 2 of them inside of here, so we can still use the same strategy. The strategy here is to multiply everything by the LCD, which in this problem is pretty simple because this has a denominator of 3, this has a denominator of 3. These 2 terms have a denominator of 1, so between 3 and 1, my LCD is 3. What we need to remember to do, though, is multiply every term by that 3. So I'm going to have 3 times 6b minus 4 over 3 minus 3 times 2. This needs to be multiplied by 3 as well. 3 times 18 minus 4b over 3, and then 3 times b. Every term up here gets multiplied by 3. These 2 cancel out. These 2 cancel out. So I'm left with 1 in front of here, which if I distribute just keeps everything here the same, minus 6 These two canceled, so I just have the 18 minus 4b on top, and then plus 3b right here. Now this is something we solved in chapter 3, I believe, an equation with variables on both sides, so I'm going to simplify. 18, this will be minus 1b. I'm going to add 1b to both sides. So I have 7b minus 10 equals 18. Add 10. 7b equals 28. When I divide by 7, b is 4. Here's our last example, and it kind of shows us what we need to do if we don't have the big fraction bars. Now really this term right here is the same as saying this is y minus 1/3 all over 4. So if you would prefer to write these fractions as just a big fraction bar over that denominator, that's a choice that you have. So this one right here would be minus, and then I have y minus 3 all over 6. We don't need to rewrite it like that, but if it helps you, go ahead. What we really need to look at is our fractions and start trying to figure out the common denominators. I'm not going to deal with this fraction inside of the parentheses. What I'm looking for are the coefficients, which would be this one, and this one. These are the three fractions I need to consider when I'm trying to find my LCD. The LCD between these three numbers, 4, 6, and 3, is 12. So 12 is the number I'm going to multiply everything by. This is one term, so it's going to be 12 times 1/4 times my stuff in parentheses, minus 12 times 1/6 times everything in this parenthesis, equals 12 times 2/3. Cross-canceling is just the same, so I'm going to do 12 times 1/4 and get 3. Some people are tempted to distribute the 12 into the parentheses as well. I'm just dealing with the number in front. Let's just figure out what the number in front is before we distribute. 12 times 1/6 is just 2. And 12 times 2/3, I'm going to have to cancel that off a little bit. 4 times 2 is 8. I'm almost rid of all my fractions. I got this little guy in here, but this will go away when I distribute. Watch how this happens. I have 3y here. 3 times 1/3 is a nice whole number. Minus 2y plus 6, because I'm distributing a negative 2 here, equals 8. Combine like terms. I have just one y left. Negative 1 and 6 is a positive 5. Minus 5, y equals 3.